Welcome you all to YouTube live classes of 11th class. I am SARITA MOHANTY, lecturer in chemistry from DEVI Women's HSS. We are learning unit 12th of your syllabus, that is organic chemistry, some basic principles and techniques, and today is the last class of this chapter. So let us have a quick recap of the syllabus of what we have covered till date. So in this chapter we have covered what are organic compounds, the classification, the nomenclature. Till now we have covered the classification, the IUPAC, nomenclature, the electronic displacement, that is inductive effect, electromeric effect, resonance, hyperconjugation. In the previous class we covered hyperconjugation, homolytic and heterolytic fission of the covalent bonds. We have covered carbocations, carbanions, and today class we are going to cover electrophiles, what are free radicals, electrophiles, nucleophiles and types of organic reaction. And if time persists, we will start a new chapter of your syllabus, that is hydrogen. So let us start with today's class with free radicals. So what are free radicals? As we are already discussed that free radicals are formed due to the homolytic fission of a covalent bond. So suppose A and B are there and the bond breaks in such a manner that the shared pair of electron are distributed equally between A and B. मार्क कर गोटे बॉन्ड केमती तैयारी हुए ए गोटे इलेक्ट्रॉन देथो बी गोटे इलेक्ट्रॉन देथो बट जदि बॉन्ड टा एमती ब्रेक हबो जे ए टा निज इलेक्ट्रॉन बैक कर नबो बी टा निज इलेक्ट्रॉन बैक कर नबो दैट इज कॉल्ड होमोलिटिक फिशन एंड वी गेट फ्री रेडिकल्स इज रिजल्ट ऑफ होमोलिटिक फिशन. तो होमोलिटिक कोन मिलिबो ए डॉट बी डॉट. These things we have already discussed in the homolytic fission of the covalent bonds. Now these are called free radicals. So what are free radicals? Now free radical, first of all we know that they have unpaired electron. It जो गला electron टा कौन कला? They constitute an unpaired. They have unpaired electron and second they are neutral species. So you must remember 2 points. They have unpaired electron and second one is they are neutral. एठी कौन सी नेगेटिव साइन हबनी कहीं ना मार्क करो एटा इलेक्ट्रॉन देइथिला और एटा निज इलेक्ट्रॉन गोटे देइथिला गोटे नै गला. सो देयर वोंट बी एनी नेगेटिव चार्ज ओवर ए. So what are free radicals? Now free radicals may be an atom or group of atom having an odd or unpaired electron. I mean discuss kale usually formed by the homolytic fission of the covalent bond or they are neutral species. These are some examples where free radicals are being formed. Suppose I have already told you for the formation of the free radical there must be some energy source that may be mark here H nu lekha aichi, there may be H nu or the symbol delta or UV light or peroxide, this must be written on the arrow. Okay. So these provide energy for the breakage of homolytic fission. So this is an example where chlorine, two chlorine atom they are breaking according to homolytic fission and each generating a chlorine free radical. Eti kon lekha is dekho chlorine free radical. Similarly here CH3 and CH3. CH3 they are forming methyl free radical. कौन करछन्ती each is forming a methyl free radical. तो free radical विषय जानले बर्तन. Now let us see the stability of the free radical and how they are classified. The free radicals are classified as primary, secondary, tertiary like your carbocations and carbanions. So if the unpaired electron is present on a primary carbon, it is called primary free radical. If the free radical or unpaired electron is present on a secondary carbon, it is called secondary free radical. Similarly, tertiary free radical. Mark the example here. Here The unpaired electron, here the unpaired electron is present on a primary carbon. Here, hence it is called primary free radical. Here, the unpaired electron is present on the carbon which is attached to two more other carbon atoms, hence it is called secondary free radical. And here, the unpaired electron is present on the carbon which is attached to three other carbon atoms, hence it is an example of tertiary free radical. जेमती कार्बोकैटायन कार्बानियन को कहते exactly same mode of classification is applicable for free radicals. Now let us see the stability of the free radicals. We have already discussed the stability of the free radical in the hyperconjugation chapter. So what are the stability of the free radical can be explained on the basis of hyperconjugation. That is, tertiary will be more stable than the secondary than the primary. It is due to hyperconjugating effect. Let us see. Suppose, mark here, in case of a tertiary free radical CH3 and CH3, there is the presence of free radical over here. So, this free radical may hyperconjugate with this hydrogen. Hyperconjugate with this hydrogen. How many alpha hydrogens are there? 3 plus 3 plus 3. So, in total 9 hyperconjugating structures can be written for this free radical. So, more is the number of hyperconjugating structure, more is the stability. Hyperconjugating structure kemti asibo? Now, more is the number of alpha hydrogen, and we have discussed it in detail in the hyperconjugation part. Higher the number of alpha hydrogen atoms, greater will be the delocalization of the reason is same. The hyperconjugation always leads to delocalization of the odd electron in case of free radical. Carbocation re kon hotla na hyperconjugation leads to the delocalization of the positive charge. So, hyperconjugation always leads to the delocalization of the odd electron, as a result of which the structure becomes more stable. Hence, the order of stability is tertiary free radical will be more stable than secondary than the primary. This is the structure of your free radical. Let us see, we know that how to calculate the hybridization, you have to calculate the number of sigma bonds. So, how many number of sigma bonds are there? 1, 2 and 3. Since 3 number of sigma bonds are there, the hybridization will be sp2 and one pz orbital will be there. This is the pz orbital containing one odd pair of electron. It is tinta hybridization will be sp2. So, the structure will be planar, bond angle will be 120 degree, having gote एठी कौन रहइबो vacant p orbital, vacant तो नुहे गोटे p orbital रहइबो containing one odd pair of electron. This is the structure of the free radical. Now see what are the attacking reagents. आमे आसिया बर्तमान डिस्कशन करिया what are electrophiles and nucleophiles. Electrophiles and nucleophiles are attacking reagents. What are attacking reagents? Attacking reagents are chemical species which attack a substrate molecule to give you the product. So, attacking reagents are of two types, that is electrophilic attacking reagent or electrophiles, and nucleophilic attacking reagents or nucleophiles. Let us discuss it one by one. So, if what is an electrophilic, it comes from two words, that is electro comes from electron and philic means loving. Electron loving species are called electrophiles. तो who will love electron ना who will be deficient in electron जहार electron नथिबो that will have more affinity towards the electron. So electrophiles will be कौन से को टाइप रो चार्ज हबो ना they are positively charged species मन रख था. So electrophiles are positively charged or neutral species having deficient in electron. तांकर either positively charged रहितबे किंबा the atom present in them must have deficiency in the electron. So let's discuss one by one. So electrophiles are electron loving chemical species. They have a tendency to accept an electron pair from another species. Hala. तो why? Because they have एटी कौन लिखा है देखो because they have an electron deficient atom जोड़ा हम कहली एबे they must have either they must be positively charged or they must have an atom which is deficient in electron. Example देखिबा so electrophiles are divided into two types positive electrophile and neutral electrophile. देखो these are positively charged तो सेमानकर सबले कौन affinity थिबो to gain electron. Similarly neutral electrophile mark here aluminum chloride AlCl3 देखो कौन होची aluminum Cl and another Cl. So aluminum is forming 3 bonds with 3 chlorine atoms. So how many number of valence electron is there? 6 तीनटा bond करछि माने केतरा electron valence electron अछि 6 valence electrons are there. So octet satisfy होछि कि होनी so it will act as a कोन तार tendency सब लइथो to gain 2 more electron. Hence since aluminum has not satisfied its octet so it will have a tendency to gain 2 more electron and hence it will act as a electrophile. Neutral electrophile. The neutral electrophile हमें कौन देखले the neutral electrophile must have an atom which has not satisfied its octet and hence it will always have a tendency to gain more electron. Similarly एठी देखो BF3 same case it has not the boron has not satisfied its octet so it will have more tendency to gain electron. Same case for zinc chloride and they all act as all these electrophile attacks as Lewis acid. What are Lewis acid? Something which accept electron are called Lewis acid. Since they are accepting the electrons, they all are called Lewis acids. है इटा बहुत थोड़ा क्वेश्चन आसे जे इलेक्ट्रोफाइल कौन Lewis acids हाँ कि ना you remember that since they accept electron they will behave as Lewis acid. Now nucleophiles same thing nucleus loving species are called nucleophiles. Nucleus कौन nucleus are positively charged तो positive charge प्रति कहार affinity थिवो ना गोटे negative charge. So nucleophiles are negatively charged species or they must have unshared pair of electron which they can share with other. Either तांको पाखरे negative charge अच्छी किंबा unpaired electron अच्छी जोटा कि सेमाने अन्य को दे परिवे देखिबा. So nucleophiles are basically are of two types that is neutral nucleophile and negatively charged nucleophiles. देखो so negatively nucleophiles देखो negative charge are there OH minus Cl minus Cn minus these all are negatively charged hence they will attack a positive center. Similarly neutral nucleophiles देखो एटी केतरा lone pair अछि देखो फॉर एग्जांपल न्यूट्रल न्यूक्लियोफाइल एग्जांपल होची अमोनिया. Ammonia the nitrogen after the formation of 3 bonds will have one lone pair of electron over it. the extra lone pair achi, so it can donate that electron, hence it will act as a nucleophile. Similarly, water dekho, water has 2 lone pair of electron over oxygen, hence it can also donate that electron at the time of need. So, water also acts as a nucleophile. Your RNH2 amines, here nitrogen also has lone pair over it, so it can also donate electron. So, these are the example of some neutral nucleophiles. So, remember that nucleophiles are of 2 types, that is negative nucleophile and neutral nucleophile, and neutral nucleophile must have an atom with unshared pair or with a lone pair of electrons. Now, let us see what are the types of organic reaction. So, organic reactions are broadly divided into 4 types, that is substitution reaction, addition reaction, elimination reaction and rearrangement reaction. Let us discuss these reactions one by one. First of all, let us see what is a substitution reaction. When an atom or group of atom in an organic molecule are replaced by an equivalent number of atoms without any change in the structure of the remaining part of the molecule, then the reaction is termed as substitution reaction. For example, देखिए what is substitution reaction. Here mark, here this Z. Mark, here the Z atom is substituted by Y atom. Z is substituted by Y, and mark that the bond making and breaking takes place at the same carbon and the remaining part of the molecule remain unchanged. केवल कौन है Z बदल रे Y टा लगिला, and this Z which leaves the molecule is called leaving group. कौन कहा जाए जोटा molecule छाड़ी की जाए कहा जाए leaving group. Which enters into the molecule is called substituent. Which enter into the molecule is called substituent. So, Y is the substituent and Z is the leaving group. Z पड़ेला तापदले कौन हला Y लगेला. All the remaining part of the molecule remains the same. Hybridization of carbon is remaining same, किछि change होनी. सेथिपाई such type of reaction are substitution reaction. That is, in substitution type of reaction, कौन हबो ना an atom or group of atom will be substituted by an equivalent atom and the remaining part of the molecule will remain same. And another important thing is that the bond making or breaking takes place at the same carbon atom. से समान कार्बन पाखे रे ही हबो. जो कार्बन रो लिविंग ग्रुप जाइथिबो सेही कार्बन पाखे रे ही सब्स्टिट्यूएंट टा लागियो. Let's see an example of So, these are the characteristic reactions of saturated compounds. Saturated compounds माने जो थे केवल single bond थिबो એટલે double bond नथो. These are the characteristics reactions of saturated compound like your alkyl halides, alcohols ହେଲା से माने एटा देखंती. Let's see here this iodide molecule, this iodine atom is being substituted by Cl minus. As a result, you are getting CH3Cl and I minus. So, here Cl is the substituent and I minus is the leaving group. Similarly, OH minus is attacking this R and X is leaving. So, X is the leaving group and OH is the substituent. Now let us see the substitution reaction types. Substitution reactions are divided into two types. Substitution reactions are divided into three types, that is nucleophilic substitution reaction, electrophilic substitution reaction and free radical substitution reaction. Depending upon the attacking reagent which brought about the reactions, the substitution reactions are divided into three types, that is nucleophilic, electrophilic and free radical substitution. If a nucleophile brings about a substitution reaction, then it is called nucleophilic substitution reaction. If an electrophile brings about the substitution reaction, it is called electrophilic substitution reaction. If a free radical brought about the reaction, it is called free radical substitution reaction. Let us discuss one by one. Nucleophilic substitution reactions are further divided into SN1 and SN2. These are brought about by nucleophiles. Here what happens? A strong nucleophile displaces a weaker nucleophile. Got a strong nucleophile asibo and it will displace a weaker nucleophile. Usually these are shown by alkyl halides. This is an example of substitution reaction. Here OH minus attack this carbon, OH minus attack this carbon and this Br minus, Br leaves. OH minus ta attack kala, Br ta padela. So you get this alcohol and Br minus. So what is the leaving group? Br minus will be the leaving group and OH minus is the substitute. Jehetu OH minus, since a negative charge is carrying out the reaction, hence the name nucleophilic substitution reaction. Now, nucleophilic substitution reactions are of two types, that is substitution nucleophilic bimolecular, substitution nucleophilic unimolecular. Just remember that if it is according to the kinetics of the reaction, and this will be discussed in detail in your alkyl halides chapter in the class 12 jora class 12 re achi. If the rate of the reaction jota ki already achi, if the rate of the reaction depends on the concentration of the both the substrate as well as the nucleophile, then it is called bimolecular. But if the reaction rate of reaction mane kete shighra reaction ta habo, that depends only upon the concentration of the substrate, then it is called unimolecular. Okay. So if here SN2 mane mon raktha, if the reaction rate R is proportional to substrate concentration as well as nucleophile concentration, देखो दीटा ऊपर डिपेंड करची, सेथमे कौन कहा गला bimolecular. Rate टा कहा दीटा ऊपर डिपेंड करची, both the concentration of the substrate as well as concentration of the nucleophile, सेथमे कहा गला bimolecular. But if the rate केते शीघ्र reaction टा हबो, if the rate depends upon the concentration of the substrate only, nucleophile upare depend करे nahi, then it is called unimolecular, and these things will be discussed in detail in class 12. Okay. एबे खाली brief idea गोटे जानी था. Now see what are electrophilic substitution reaction. If a electrophile brings about the substitution reaction, then it is called electrophilic substitution reaction, and electrophilic substitution reaction are characteristic of benzene or its derivative. केवल benzene और derivative गुड़ा electrophilic substitution reaction दिखाती. काहे की देखा? देखो benzene, जितने हम benzene टा लिखुची, benzene has 6 pi electrons, 2, 1, 2, 3. So 6 pi electron. So whether it is an electron rich system or deficient in electron, it is an electron rich system. मन रखते हैं कौन? Electron rich. It is an electron rich system. सो गोटे इलेक्ट्रॉन रिच सिस्टम पाखु किए आसीबो पॉजिटिव चार्ज हेंस द रिएक्शन इज ब्रॉट अबाउट बाय एन इलेक्ट्रोफाइल तो यहाँ सब क्या अट्रैक्ट करे गोटे पॉजिटिव चार्ज को सिंस इट इज रिच इन इलेक्ट्रॉन एंड brings about the reaction electrophilic substitution reaction and this will be discussed in detail in your कोथरे जेतेबेले आमे पढिबा बेंजीन जेतेबेले पढिबा सेतेबेले डिटेल देखिबा हला this is an example of your electrophilic substitution reaction here this is Cl plus chloronium ion. Chloronium ion is actually displacing this hydrogen and in place of H this chlorine atom is getting substituted. Hence, it is example of electrophilic substitution reaction. Now, free radical substitution reaction. If a free radical brings about the substitution reaction, then it is called a free radical substitution reaction and such type of reactions are shown by alkanes. If alkanes पढ़िबो एटा डिटेल पढ़िबो सेतले देखिबो देखा एटी कोन लिखा है UV light कोन लिखा UV light so UV light अछि माने कोन हबो homolytic fission so in presence of UV light the chlorine get homolytically सारा breakage हुए breakage है कि chlorine free radical बाहर एटी कोन बाहर chlorine free radical and this chlorine free radical brings about the substitution reaction by attacking this carbon को attack करी since this reaction is initiated by a free radical hence the name free radical substitution and this will be discussed in detail in your alkane chapter. So, let us move on to the second type of reaction, addition reaction. So, what are addition reaction? Now, addition reactions are those reactions in which two molecules they combine together to give a simple molecule. They combine together. Addition ना देखो जहाँ reaction रो ना सेटा ही हबो addition माने कोन दीटा मिसुचंती molecule so in which two reacting molecules they combine and give you is another simple molecule it is called addition type of reaction okay so addition type of reaction किए देखा है ना unsaturated compounds that is compounds having double bond or triple bond they show addition type of reaction why they show addition type of reaction because in addition type of reaction the pi bonds get converted into sigma bond gotte pi bond bhangi dita sigma bond habo and as we know the sigma bonds are more stable than the pi bonds sethi pai eta kiye dekhanti na double bond or triple bond jo thae semane kon karanti bhangi ki pi bond ta convert hue sigma bond ko so this is an example here mark CH2 double bond CH2 plus hydrogen mark here all the pi bonds are getting converted into sigma bond eta heitho kemti dekho eta heitho e type ro CH2 CH2 H H तो पाइले कोन CH3 single bond CH3 दीटा molecule मिसले गोटे molecule देले So, addition reaction are of three types that is nucleophilic addition reaction, electrophilic addition reaction and free radical addition reaction. Just like your substitution reaction, if a nucleophile brings about the addition reaction it is called nucleophilic addition reaction. If an electrophile brings about the addition reaction it is called electrophilic addition reaction and if a free radical brings about the addition reaction it is called free radical addition reaction. So, let us discuss one by one. So, if a nucleophile brings about the reaction it is called nucleophilic addition reaction and it is remember that it is usually shown by aldehydes and ketones. एटा किए देखा है aldehydes and ketones. Why मैंने कहीं देखा है देखो because mark that in case of aldehyde C double bond ओ एटा होची कोन aldehyde हो किंबा ketone हो mark the carbon here oxygen is more electronegative than carbon so as a result I can also write so it can take away this pi electron towards itself as a result this carbon will have a positive charge while this oxygen will have a negative charge eta kai ho jani parcho to because oxygen is more electronegative than carbon setme tar tendency सबले थियो जो electron नहीं जाए so carbon develops a positive charge so which will attack a positive center a nucleophile गोटे negative charge ही attack कर परिबो कोन positive center nucleophile आसिला एवं attack कला hence aldehydes and ketones where the carbon is having partial positive charge are attacked by a negative charge that is a nucleophile hence they undergo nucleophilic addition reaction double bond अछि तो addition हबो कार्बन ऊपर पॉजिटिव चार्ज अछि तो न्यूक्लियोफाइल अटैक करियो एतो मन रखियो न्यूक्लियोफिलिक एडिशन रिएक्शन नेक्स्ट इलेक्ट्रोफिलिक एडिशन रिएक्शन दिस इज एन एग्जांपल ऑफ न्यूक्लियोफिलिक एडिशन रिएक्शन हियर Cn- देखो एडी कोन होची Cn- cyanide माइनस ता कोन करची अटैक करची कहा को अटैक करची कार्बन एठी कार्बन partially positive charge always it is partially positive charge so carbon ऊपर अटैक करची अटैक करके देखो लास्ट को कोन होची Cn गोटे मॉलिक्यूल पाउछ Now these reactions will be discussed in detail in your aldehyde and ketone chapter which is present in class 12th. So देखिए electrophilic addition reaction if the addition reaction is brought about by an electrophile माने गोटे positive charge रे reaction ता start करथो then it is called electrophilic substitution reaction. So which will देखो ताले एटा किए करिवो ना these are the characteristic reactions of alkene and alkyne देखो कहीं देखो C double bond C. So whether tell me whether it is an electron rich system or electron deficient system. It is an electron rich system. मन रखता always the pi electrons are always electron rich system है ना तो सेथिमें जेहेतु एटी pi electrons अछि so the pi electrons will always attract a positive charge. सेथिमें किए reaction start करिवो ना electrophile तो हैला कोन तुम्हारा electrophilic addition reaction. Alkenes and alkynes since they are rich in kono electron system or pi electron they attract a positive charge or electrophile towards themselves and this initiate the reaction hence the name electrophilic addition reaction. एटी गोटे example दिया है देखो addition of HBr to alkene addition of HBr to alkene एटी कौन हो देखो electron rich system देखो ये first किए ऐड है देखो the pi electron are attracting this H plus towards themselves है pi electron टा electron rich system कहाँ को attract करची HBr को part टा को attract करची positive part टा को निज आड़ को attract करची hence the name electrophilic addition reaction and these are the reaction which we will study in detail in alkene chapter. Alkene chapter जो first year पढ़िबा से एटा डिस्कस करे हला सेमती फ्री रेडिकल एडिशन इफ द रिएक्शन इज ब्रॉट अबाउट बाय फ्री रेडिकल देखो एटी के स्टार्ट करची पेरोक्साइड कहितले पेरोक्साइड थिला माने सब कोन हबो फ्री रेडिकल एडिशन हबो एटी कोन जनरेट हला फ्री रेडिकल डॉट अछि सो दिस फ्री रेडिकल इज generating another free radical Br free radical bromine free radical hochi and this bromine free radical is actually starting the reaction hence the name free radical addition reaction. Now elimination reaction is just the reverse of the addition reaction hla addition reaction रे कोन होची addition reaction रे double bond भांगी sigma bond तयारी होची जेतबेले कि elimination reaction रे sigma bond भांगी तुमर कोन हबो pi bond तयारी हबो so water elimination ना कोन कहूची किछिटा molecule eliminate हबो so what is elimination reaction now which involve the loss of two atoms hela or group of atoms remember from the same or adjacent atoms of the reactant molecule माने दीटा atom अछि कार्बन कार्बन अछि adjacent atom रो हे पारे किबा same atom रो हे पारे जदी किछि atoms loss होकी तमरो डबल बॉन्ड तैयारी होची कि ट्रिपल बॉन्ड तैयारी होची that is called elimination reaction. Elimination reaction always leads to the formation of unsaturated compounds. So these are the methods of preparation of alkenes. आमे देखिबा alkenes रे elimination reactions are used to prepare alkenes. Example देखिबा देखो एठी कोन होची एठी कार्बन सेम एडजेसेंट कार्बन पाखरु x जाउची आ एठी ए कार्बन पाखरु कोन जाउची h जाउची in presence of alcoholic KH. This reaction is very important. Both entrance और board पे बहुत थोड़ा अच्छी reaction टा entrance रे. So in presence of alcoholic KH मन रखो aqueous KOH brings about the substitution reaction, while alcoholic KOH plus ethanol, they brings about the elimination reaction. So in presence of alcoholic KOH, adjacent carbon atom they loses HX molecule. कौन जाए HX molecule alkyl halide रे जाए कि they form alkene. So this reaction will be taught to you in alkene as well as alkyl halide. एटा दी थर पढ़िबा alkene रे पढ़िबा plus alkyl halides रे भी पढ़िबा. Next reaction देखो आमे कौन कहतले in elimination reaction can occur if atoms are lost from the same molecule or from adjacent molecule. This is also very important reaction. This is the reaction of alkyl halides with zinc. In presence of zinc, the halogen atoms are removed from the adjacent atoms. As a result, we get alkenes. These are the two examples of elimination reaction. Simple one रखो elimination reaction माने eliminate हो उड़े simple molecule टे substrate टू बाहर जाए कि तुमको double bond किंबा triple bond दबो product रे. So with this we have completed the unit 12, that is organic chemistry, some basic concepts and principles. Remember that तुमको starting रू ही कहथली this chapter is very important because it forms the foundation of the entire organic chemistry. So please I suggest that you read it from any standard book and you watch the videos first and then you study the books, then it will be easier for you to understand. And remember that you try to do as many problems you can do from this chapter. तुम्हारा 11th अच्छी बर्तन बोर्ड नहीं तो तुम्हें आराम से बर्तन टाइम देकी पढ़ी पारिबो. तो एई चैप्टर टाकू पर्टिकुलरली तुम्हें माने कोनोसी गोटे स्टैंडर्ड बुक्स रु पढ़ो आउ प्रॉब्लम्स जते करि पारछो करो. ऑर्गेनिक केमिस्ट्री एंटायर केमिस्ट्री तुम जते प्रॉब्लम करिवो तुम आइडियाटा सेते अधिक कोन हबो ब्रॉड हबो. यू विल हैव ए वेरी क्लियर आइडिया रिगार्डिंग द थ्योरी पार्ट. So with this let's start our next chapter, hydrogen. So this is your unit 9 hydrogen and today we are going to start with this chapter hydrogen. Let's have a look what is the reduced syllabus proposed in the hydrogen. Hydrogen re kon syllabus ta achi. So we have to study the position of hydrogen in the periodic table, its occurrence, the isotopes, the preparation, properties and uses of hydrogen, also the hydrides and the physical and chemical properties of water, heavy water and uses of hydrogen as fuel. These are the reduced syllabus given by the CHSC. So let us have a brief introduction regarding the hydrogen. Hydrogen is the most abundant element of the universe, entire universe ramandakta. 70% mass of the entire universe is because of the hydrogen. It is also the lightest element known and it is the element which forms maximum number of compounds. It gote element जोटा कि maximum number of compound तैयारी करे. आउ कौन सी element आ भले अधिक compound तैयारी करी पारंती नहीं. For example देखो the water which forms the basic of our life. Water होची कौन? Water forms the basis of the life. And what is water? Formula is H2O. Water is nothing but an oxide of hydrogen. Hydrogen and oxygen combines to give you water. Not only water, your carbohydrates, proteins, nucleic acid, जो गुड़ा आम बॉडी भीतर अच्छी, they all are तुम कार्बोहाइड्रेट्स, प्रोटीन्स, लिपिड्स, न्यूक्लिक एसिड जहाँ भी तुम आम बॉडी देखू सबुतक they all contain hydrogen with itself है. Similarly our solar system, the whether it is sun or most of the stars, there half of the mass of most of the stars are usually due to hydrogen. The energy which we are getting from the sun is actually due to the fusion reactions. In fusion reaction, the hydrogen combines to give you helium, in which a large amount of energy get released. तो देख entire universe रा कहया गले basic टा किए करची hydrogen है. Though it is the last element, it is the lightest element and it is the first element of the periodic table. So the normal hydrogen contains one proton in the nucleus and one electron revolves around it. It देखो hydrogen कौन लिखा जाए 1 1. Its mass is 1 and atomic number is also 1. Mass is approximately 1.0079 atomic mass. Now let us have a brief discussion about the history of hydrogen. This is Henry Cavendish. He first discovered the hydrogen in 1766, but the name hydrogen was proposed by Lavoisier. French chemist na सुनथिबो Lavoisier. He proposed the name hydrogen because he saw that hydrogen produces water when it burns in oxygen. Oxygen रे burn कला कोन होची water तयारी करची. Hence he proposed the name hydrogens. Hydro means Greek water, Greek words. Hydro means water, gen means producer. Since it is producing water, water producer. तो ना हला कोन hydrogen हला. Now let us discuss about the position of hydrogen. Hydrogen is really very special because till now its position is ambiguous. Whether to place the hydrogen in the group 1 or group 17, it is still very ambiguous. So let us discuss how it is being ambiguous. Like देखिए, ये देखो first periodic table लो तुम्हारा first position रे किए था hydrogen था. Table is your hydrogen. तो देखिए hydrogen किंतु मार्क करो जितेबाला आम पढ़ा जितेबाला आम पढ़ा ग्रुप 1 देखियो ग्रुप 1 रे हाइड्रोजन इज नॉट इंक्लूडेड. आम ग्रुप 1 टा स्टार्ट करछु कोठू लिथियम सोडियम पोटासियम रेडियम लिथियम सोडियम पोटासियम रुबिडियम सीजियम फ्रांसियम. वी आर नॉट रीडिंग हाइड्रोजन इन ग्रुप 1. व्हाई? बिकॉज इट हैज a special position. Hence we are reading hydrogen is separate chapter. आम गोटे separate chapter भावे पढ़ुचे है. Position of the hydrogen in periodic table. Mark the word proper position could not be assigned to hydrogen whether it is in Mendeleev's periodic table or in modern periodic table. को थरे भी ताको proper position दिया जाए पारिनी. काहे की देखिबा? Because it has some properties which are similar to group 1. Whereas it has some properties which are similar to group 17. माने पूरा एक्सट्रीम एंड देखो ग्रुप 1 टा रहला पीरियोडिक टेबल लो स्टार्ट रे ग्रुप 17 टा रहला ऑलमोस्ट पीरियोडिक टेबल लो शेष रे. तो दीटा को सहित आ प्रॉपर्टी कोन करे सेम रहे. प्लस it has its own properties which differ it from alkali metals as well as halogen atoms. तो देखिए one by one. In some properties hydrogen resembles alkali metal, in some properties it resembles halogen, and yet in some other properties of hydrogen differ from both alkali metals as well as hydrogens. So the position of hydrogen in the periodic table is still anomalous. ए पर्यंत भी ठीक नहीं. देखिए next देखिए. So what are the resemblance with alkali metals? How the hydrogen resembles with alkali metal? First is the electronic structure. We know that तुम्हें समझते periodic class मन रखता ए चैप्टर टा पढ़िबा पूर्वरु inorganic पढ़िया पूर्वरु you must have read your unit 3, that is periodic classification of elements. सेटा न पढ़िले तुम्हें एटा किछि बुझि पारियो नाही. So first you have to read that chapter. Okay. So electronic configuration of alkali metals देखो. In case of lithium, it has one electron in its valence shell. Similarly, sodium has also one electron in its valence shell. Hydrogen also having one electron in its valence shell. समस्तंग outermost shell ले कितना electron अछि? One electron. So electronic configuration अनुसार एटा alkali metal से तो similarity देखाए. Second देखिबा, Electropositive character, we know that alkali metals loses one electron and form Na plus kimba Li plus kimba potassium plus kaiki, because by losing one electron they will have the nearest noble gas configuration. तांकर outermost रे गोटे इलेक्ट्रॉन थाए, से इलेक्ट्रॉन टा दे देले से माने कौन करंती नियरेस्ट इनर्ट गैस कॉन्फ़िगरेशन पाइबे. फॉर एग्जांपल सोडियम, योर सोडियम आफ्टर लूजिंग वन इलेक्ट्रॉन फॉर्म Na प्लस. यार कॉन्फ़िगरेशन कौन 1s2 1s2 2s2 2p6. एटा कहा से तो समान होची नियॉन से तो कॉन्फ़िगरेशन आछी कि नहीं. Similarly, and it is forming Na plus. Similarly, we know that hydrogen forms kona H plus. So, like alkali metals, it is forming H plus. Second similarity. Now, third similarity देखिए oxidation state. Your alkali metal shows +1 oxidation state. Similarly, the hydrogen also show +1 oxidation state. देखो जेमिति NaCl तैयारी होची, देखो एठी कौन तैयारी होची HCl. Na plus एठी oxidation state केते +1. Similarly, hydrogen is also forming +1 in its compounds. Okay. Combination with electronegative elements or metals. देखो hydrogen can combine with oxygen as well as sulfur and also chlorine, forming देखो एटी कौन करची hydrogen oxide माने water, एटी hydrogen sulfide, एटी कौन करची HCl. एटी देखो सोडियम भी सेमती कौन करची, सोडियम जेमिति कंपाउंड करची एक्जाक्टली सेमती हाइड्रोजन भी कंपाउंड करची कहा सहित ना इलेक्ट्रोनेगेटिव एटम एलिमेंट्स को सहित ऑक्सीजन सल्फर एंड क्लोरीन. रिड्यूसिंग कैरेक्टर, योर sodium your group 1 metals are strong reducing agents. Similarly, your hydrogen also is a strong reducing agent. Mark here, potassium here is reducing this boron trioxide to forming boron and K2. It is कौन boron is losing oxygen and forming boron, that is oxidation is taking place. What is a reducing agent? मन रखो LIC agent. LIC agent कौन करे अन्य मानकर पॉलिसी काढ़े. So reducing agent is something which reduces others है जोटा कि अन्य को reduce करियो. So it acts as a strong reducing agent माने ये अन्य को कौन करे अन्य को सहजरे reduce कर पाए. देखो example एठी आयरन ऑक्साइड अच्छी, आयरन ऑक्साइड सहित हाइड्रोजन रिएक्शन करची करी कौन दोची आयरन मेटल दोची. Iron has lost its oxygen and forming iron metal. So iron is getting reduced and hydrogen itself is getting oxidized. So these are some similarities between hydrogens and alkali metals. These are their electronic configurations are same. They have one electron in its valence shell. They show electropositive character. They show +1 oxidation state, and they all act as strong reducing agents. Okay. Now let us see what are the resemblance with halogens. Now see, halogens has fluorine. It has 7 electron in its outermost configuration. So it can accept 1 electron and have the configuration of neon. Similarly, hydrogen is having 1 electron in its outermost shell. So it can gain 1 electron more and get converted to the nearest inert gas configuration. That is, they कौन कर परियो H minus गोटे इलेक्ट्रॉन आनला आणि कहा बळे कॉन्फिगरेशन पळे आसला हीलियम. एटा होची फर्स्ट सिमिलरिटी. सेकंड सिमिलरिटी होची दे हैव इलेक्ट्रोनेगेटिव कैरेक्टर. देखो halogens कौन करंती, since halogens have 7 electrons in its outermost shell, so they have a tendency to accept 1 electron and get converted to halide ions. Man सहजरे कौन कर परंती x टा convert हबो. Halogens are always denoted by x sign हैला. x टा electron accept करिवो, accept करी कौन कर परिवो x minus हैला. Similarly, the hydrogen can accept 1 electron forming H minus. Sometimes hydrogen can also accept electron forming hydride. This is the second similarity. Ionization enthalpy. What is ionization enthalpy? It is the amount of energy which is required to remove an electron from a gaseous neutral atom. गोटे atom रू गोटे electron काढ़िया पई तुमको जेतिकी energy use करिया को पड़े, that is called ionization enthalpy. So if we compare the ionization enthalpy ru kon janle, more is the ionization enthalpy, lesser is the tendency to lose the electron. Jahar ionization enthalpy jete adhika habo mane tar electron taathu naba sete adhika kashta. So if you compare the ionization enthalpy of hydrogen, we see that the ionization enthalpy of hydrogen is comparable to the ionization enthalpy of the group 17 elements. Group 1 रे देखो कितने कम आछि, लिथियम रो 520, सोडियम रो 496 किलोजूल पर मोल, पोटासियम रो 419. जितेबाला कि हाइड्रोजन देखो आयनेशन एंथैल्पी 1312 किलोजूल पर मोल, जोटा कि पाखापाखि कहार क्लोरीन आउ फ्लोरीन पाखापाखि आसीबो. So its ionization enthalpy is at par with that of the group 17 elements. Then oxidation state. Oxidation state, like your chlorine, fluorine, bromine, it also form कौन देख ये कौन करची -1 तैयारी करची. So with alkali metals it form a -1 oxidation state. जेमती कि तुमरो क्लोरीन, फ्लोरीन, ब्रोमीन देखांती -1, हाइड्रोजन भी बेले बेले -1 देखे पारे है. Atomicity and non-metallic character, we know that at like your fluorine, chlorine, bromine, तार formula कौन F2 molecular जो ये F2Cl2 they exist as molecule. Similarly, your hydrogen also exists as molecule, that is H2 in normal condition. And non-metallic character, we know that fluorine, chlorine, bromine, these are non-metals. Similarly, hydrogen is also a non-metal. Now combination with metals, hydrogen combine with metals forming metal hydrides आमे पढ़ीचे. Like your halogens, सेठी कौन होची देखो सोडियम हाइड्रोजन combine करी कौन होची सोडियम हाइड्राइड. Similarly, जेमती सोडियम क्लोरीन combine करी कौन करची सोडियम क्लोराइड, सेमती हाइड्रोजन combines with metals forming sodium hydrides. Formation of covalent compounds, formation जेमती देखो एठी कौन होची एठी CCl4, SiCl4, NCl3 देख सबुठी देख कार्बन एठी क्लोरीन क्या सहित कंबाइन करछि कार्बन सहित, एठी सिलिकॉन सहित, एठी नाइट्रोजन, these are कौन these are carbon silicon combined with non metals. Similarly, your hydrogen also combined with carbon, silicon, nitrogen forming कौन covalent compounds. So this is the another similarity with group 17. Replacement reaction देखियो जेतले हम organic chemistry पढ़छु देखियो many times the in carbon compounds the hydrogen can be substituted with the halogen compounds. बहुत समय देखियो hydrogen कौन करियो halogen सहित substitute हे परछि किंबा vice versa. So replacement or substitution reaction. So these are the similarity of, we have discussed, these are the similarity of carbon with group 1 and similarity of carbon with group 17. But now see that there is certain differences of its properties with alkali metals as well as halogen. Halogen actually, hydrogen is less electropositive than alkali metals and less electronegative than halogens. ता अर्थ जदि आमे मेटल सहित कंपेयर करिबा एटा सेतिकी इलेक्ट्रोपॉजिटिव नुहे तांकठु आर इलेक्ट्रोपॉजिटिव किंबा टेंडेंसी टू लूज इलेक्ट्रॉन इज लेस देन दैट ऑफ द मेटल. जदि आमे नॉन मेटल सहित कंपेयर करिया माने हालोजन सहित कंपेयर करिबा देखिबा द टेंडेंसी टू गेन इलेक्ट्रॉन इज आल्सो लेस देन द टेंडेंसी of the halogens. So hydrogen is less electropositive than alkali metals and less electronegative than halogens. And alkali metals or halogens रे more than one protons थांती तांको न्यूक्लियस रे, इलेक्ट्रॉन भी अधिक थांती, but hydrogen has only one proton and one electron. So these are some point of difference between alkali metals and halogens. And the last one is oxides of hydrogen. We know that non-metals from acidic oxides and metals from basic oxide, but the oxide of hydrogen, the oxide of hydrogen, it is actually neutral. What is neutral? जेतेबेले कि metals सबले कौन करंती basic formation करंती oxide, आउ non-metals उड़ा करंती कौन acidic oxide. This is the last point of difference. So आमे देखिले hydrogen को जदिओ एटा सिमिलरिटी किछटा सिमिलरिटी देखौची ग्रुप 1 आउ किछटा सिमिलरिटी देखौची ग्रुप 17, बट यार प्रॉपर्टी तांकोठु केतरा क्षेत्र रे बहुत अलगा भी होची. So, till now we can say that hydrogen has an ambiguous position in the periodic table. With this, I am finishing today's class. In the next class, we will discuss the isotopes and the properties of hydrogen and water. Thank you. Have a good day.